Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're going to talk about LED strips. So let's dive deep into it. Now, as you all know, Diwali is coming, so it's the time where every Indian family invests a lot of money into buying these sort of things, and we just hope that it works. And apparently it's not working for some reason. Well, such is life. So it's one of those things that... So I just wanted to make this system because again, a lot of people are going to buy a lot of purchasing. So we want to make sure that they have some knowledge of what the hell is going on. So let's start with the basic. We are talking about LED decoration light. These lights are not supposed to be your work light or anything serious. These are just decoration, not basically, critical work light or video light. Because again, we are not talking about CRI. We are not talking about like color rendition and all that. Just a very simple decorative light. Now, generally, you start with the category voltage. There are two categories. One is high voltage, another is low voltage. Low voltage, anything below 48 volt, high voltage, AC mains volt. Now, recently, because of the cheapification of LED, basically this sort of strip started to flood the market. Now, they have no controller, nothing, no adapter, nothing. You just plug AC mains, 50 hertz, 220 volt here, and voila, this glows. Now, as you can understand, the only way to do that is having a lot of LEDs in series, so they act like they can handle the voltage, and it does work. It's a surprisingly cheap, surprisingly bright, however very flickery, because in India we use 50 hertz compared to USA of 60 hertz, so it does flicker a bit. However, this is dangerous as hell, because if the silicon fails, which again this has a place where silicon has failed, the conductor can come to outside, and if you touch it, it's AC mains. So it's a very hazardous thing. AC powered LED strips are not recommended. And while this was bad, for some reason somebody decided, what if we made it even more dangerous? So even this got a more worse version, which is very simple. They have what we call a DC direct drive, meaning you take AC, that is 220 volt, you send it through a bridge rectifier, which is this small, and some capacitor. That's it. Like, wait a minute, doesn't that make it almost like 300 volt DC? Yeah, that's another thing available. And again, I have seen designs of that, and again, it has been used. It is freaky. It should not be used for household purposes or any sort of indoor purpose. If you have kids or pets or things of that nature, do not look into that. Those are generally, I've only seen governmental buildings to be decorated by them. It does allow very good uniform brightness, a lot of LEDs and all that. That's the good part. Bad part is, like, because it's DC at high voltage, if it jumps through your skin, which again it will do, yeah, your brain will try to send the command, let it go, but the command will never go, because again there is no zero wave, the voltage drop crossing zero. There is no zero crossing, so you will directly. So fundamentally, high voltage, stay away from them. Those are unnecessarily dangerous, and no matter how much you trust a silicon, you have to understand they degrade. So again, this is quite a few years old. First few years I had no issue, but here still, then it cracked. Now that's a problem. If you are using this over time, it becomes dangerous. I do not like that idea. And the DC 300 volt, no. So those are high voltage. Stay away from them. They do look bright. They may even they are actually surprisingly cheap, but stay away. It's not worth for household. You could even get things like this, where it's like almost like a similar kind of system, but okay, come on. But if the lights are very flickery and you do not see to control bricks and adapters and things of that nature, and light looks way too thin, that that simply means these are direct AC drive systems. And if they're flickering, again, that will be very easy to pick up. Stay away. Trust me, this is not worth it. Me even doing this is not worth it. So yeah, stay away from AC lights, high voltage light basically. Okay, now we come to low voltage. Now there are generally 3 voltage available, actually a bit more. You have 5 volt, you have 12 volt, 24 volt and 48 volt. 48 volt is so rare, even in USA not that many people have it. 24 volt is kind of available, but generally only for white LEDs. We'll talk more about that. But 5 volts and 12 volt are very common. So what's the idea here? So you have types of LED strips. You have 1 type, 2 type, you have types of LED strips. So let's understand this, how this is working. So first is the most basic type, where you have just a simple monochromatic LED. In this scenario, it's covered by silicon. This is very simple, very efficient. Again, if you are just accent lighting something, decoration, these are quite good because again, they are very diffuse, they are monochromatic, you do not have to think about it, they are quite cheap. So this is the very basic starting point. But again, nowadays we are kind of bored from this. It's like, oh, just one color, how lame. So we want a bit more advanced feature, so to say. So we generally chase for things that are a bit more oomph. It has a bit more stuff to it. So then you will start with this sort of RGB LEDs. Now these are what we call analog RGB LEDs. Analog simply meaning there is no control IC there. It's just 3 strings of this. Basically imagine this, Control C, Control V 3 times, and one is red, one is blue, one is green. So that's what you get. Assuming this is not bricked yet, this should work. Oh yeah, voila. So yeah. This is the one working. Now you may be like, okay, why, how the heck it's giving the pattern? The pattern is coming from the control brick. And how can you recognize this is not like data lines and all that? How would you recognize? Wherever the cut line is, read it. It will clearly say 12 volt plus green, red, blue. You can easily read it. And if it's something different, for example, in this, I'll talk more about that. It will simply say 12 volt data in ground. So that's how I know this is a different thing, this is a different thing. Analog system will flat out say like, you know, red, blue, green, or in some cases, if it's RGBW light, it will say white also. Again, white could be just one channel, or it could be 2 channels where you have cold white and warm white. So those are available. These are classified as analog light. Now they are very simple. You get a simple control mechanism, and you will get a remote, something like this, and you can maybe able to do things. The battery is very low on this, so I'm strobing, fade. Yeah, you can do things. Now, however, these are not like, they are like somewhere in between compared to just a flat color versus a proper pixel LED. But again, this part is awesome in one way. If you want to design a mood light, because be mindful, mood light not supposed to be very bright. They're not supposed to be like ta-da in your face. They have to be subtle. Now, problem with this sort of pixel LEDs is like whenever you are, or even this control box, is that these control boxes are very low cost. So they generally only have 8-bit of levels, so to say, to control it. But if you want like making a video panel light or a color light, accent light, mood lights, you can drive these with high quality analog drivers. Benefit of that will generally do voltage control on low intensity, because our eyes are very sensitive to low intensity changes rather than high intensity. When you are talking about 8-bit, it has 255 levels. Here still our eyes will not register that much. On upper side, it will be like, okay, 1, 2, hundreds. It's like literally, it's a logarithmic. So brightness wise, it's not a very adequate use of same 8-bit. So having 8-bit analogically controlled, where you are just like, okay, let me fade it. You can have very soft fade. It will look amazing in camera. It will be very pleasing to human eye, because again, flicker at low brightness is really bad on these things. Not because of the LED problem with this. So many people do buy this sort of thing for, you know, experimental purposes. Do I recommend this for like, you know, household decoration? Nah, it's like almost the same, you know, not that cheap compared to like, you know, full-fledged pixel LED. So this is one option. You can do it, and again, you do get some controls over it, but it's more of like, you know, you will be better off if you actually bother to get a better controller, but at that point you will be spending more money. So that's there. Now be mindful, there is one weird type of LED, which is this. I call it funny LED because it does not make sense what the hell this is. Oh, it's still working. What the hell is happening here? Okay, so this LED almost behaves like a addressable RGB, but there is no controller. There is nothing, no controller and all that. Even though I'm looking at the ribbons, it has VCC, D in, which is data in, and ground. So I'm pretty sure this is same IC, like, you know, 2811 IC is there, but again, it's controlling 6. So it's a very weird system. Would I recommend buying this? No, because again, this does have far more interesting pattern, because again, pattern can go, it can turn off sections of LED. So pattern wise, super high complexity, but because you have no control, it's like a very half-assed approach. It's like very half-assed. This I could easily recommend if you are like you want monochromatic lighting, but you want it to change. It's very good. Here it's like, yeah, but like it's like, you know, somewhere in between. So these are weird lights, which again I hope nobody buys, because again, this is, I'm pretty sure it's like a normal controller. It's just that they did not bother to expose the data line. Again, if you expose it, you have to put controller chips and all that. So they're like, and yes, the 2811 can store enough memory on itself. The IC itself has enough memory to have some basic effects like this, or maybe something similar like that. So yeah, this is fancy option, which again I do not recommend because it's very weird. So now we come to the star of the show, the actual Pixel RGB. Now, if you find Pixel RGB weird name, imagine it this way: it's ARGB, addressable RGB. Same way our PC developed, and I'm pretty sure because of PCs these became so cheap. These were always available, but they were never as cheap. But because of keyboard lightings, and again, each keyboard could be easily consuming more than 100 of these LEDs, and again they became very popular in all of computer. Heck, even Corsair fans could have 22 of these puppies. One fan. So I'm reasonably sure it got like turbo boosted into reality. So these are becoming quite affordable nowadays, even in India. In USA, you could have easily bought it, but it was expensive. Now you can buy it for cheap. So these are what we call addressable LED or Pixel LED. People who do household lighting and decoration and all that, they generally call it Pixel. If you are from computer industry, you will call it what we refer to as addressable LED. Now in addressable LED, you will never talk about the LED because people are assuming LED is fixed. So what are other variables? Variable number one, what is the voltage? For example, I bought it for decoration purposes. This puppy is 12 volt, safe voltage, and does allow long cable runs. There is other option because be mindful, 12 volt is so high. If you directly feed 12 volt, even with PWM, you will damage, degrade, or flat out fry the LED cops. So to make sure that LED lasts, they have three. So basically each IC, each black IC is controlling three of these puppies. So Pixel here is 3 LED. Yeah, that means the precision of how precisely you can control it is a bit limited because again, you have to assume 3 of them is acting as one. Again, does that matter for decoration lighting? No, I'm not making video wall with this. So it's more than good enough. But again, if you want like a pseudo video wall, you can go into 5 volt. 5 volt is low enough where you can drive a LED with PWM without too much hassle, or you can have a low resistor. So that allows you to have one version. And again, what if you do not want like, this sort of white cob and then black IC? It looks ugly. There is an even better version, which we call WS2812B. That puppy has directly integration. Like inside this cob, there will be IC. Now again, penalty of that is it only comes in 5 volt. It's not 12 volt, and penalty of that is like generally you will get spool like this. Each spool would be around 5 meters, so to say. 12 volt can easily cross. It can barely cross almost 10 meters of distance. However, if it's 5 volt, it will not even go through one whole string. And if you have power hungry lighting effects, meaning bright colors, it's where it's firing all 3 channels. Yeah, you will have color change from one end to another end because again, it does not have enough voltage. Voltage drop would be too severe at 5 volts. 12 volt voltage drop from this point, entry point to exit point is 9 volt. So 12 volt goes in, 9 volt comes out, which is still more than enough for like, driving it and all that. Barely notice it. I was looking very closely at one, like very paying attention. There's, oh, it's actually dimmer now, but very little. Like basically from a decoration point of view, it does not matter. Even if you're paying attention, it won't matter, especially if you are not going like, white color all the time, which again, you are buying RGB LED, you're not doing white all the time. So again, usable for generally companies recommend only one spool, as in 5 meter. You can push it to 10, and data signal can go as far as you want because again, it can handle up to 2000 to 3000 LEDs. So more than enough option wise you have. So that is WS2811. You will always hear this number 2811, 12 volt, 5 volt, and then you have 2812B, which is just inside the LED. Now be mindful, many people use this sort of lighting for their permanent installation, let's say hotels, lobbies. In those sort of scenarios, this is not good enough because again, there is only one data line. So basically one LED frying itself, one microcontroller, pooping the bed. Yeah, this all is dead. So to solve that, there is a dual data path, which is generally used for permanent installation. Not recommended for decoration, is overpaying it. But if you do any sort of permanent installation where it will be a hassle to pull it out and fix it, yeah, in those sort of scenario, people pay for dual data. One of the common example is 2815. That has dual data. So it has positive 12, negative 0, and then you have data primary and data backup. So that is recommended if you are doing any sort of permanent installation. Like if you are doing a swimming pool installation and hotel lightings and all that, please do pay for that. You're like, yeah, that's expensive. Trust me, if you have to pair it out, again, it will not happen in year 1. It will happen in year 5, year 6. At that point, you will be like, thank God I did not cheap out at that point. So you have to be mindful of that sort of gotchas. So you have to be very mindful of voltage drops, and to solve it, generally all these strings will come with this sort of two pigtails. You're supposed to strip them and directly inject power. Not a very big deal because I only have 2 of them, but if I had a lot of them, yes, then I will need to do injection of power. And thankfully you can run the power from the same point. So this is DC in, I can send same DC wire. Again, as long as the wire is like thicker gauge, something like this thicker gauge wire, it would be more than enough, because again resistance of these copper tapes is quite high. Again, it's a tape, it's not gonna be very low. You can have 2 wires behind, no problem, no issue about that. 5 volt you have to, 5 volt you have to. Power injection is compulsory in 5 volt. That's why you can see, like, even you have 2 pigtail from here. So be mindful of the power drop and power injection. That's why I will recommend, for majority of decoration purposes, yeah, chasing that 1 per pixel, not necessary. Go with 12 volt, you will be happy. However, be mindful, after you have selected the, let's say, type, right, rather than analog RGB, you selected per pixel RGB, you will get the IC options. Generally, most of the time you will select 2811 simply because it's very popular. Everything about it, controller, the code, heck, you can, if you know yourself, you can even code ESP32 to directly control this. This is very common. The library is known, circuits are known, everything about this is a known quantity. But you may be like, hey, okay, I selected that LED, what about then? After then, you have to figure out what is the LED density. For example, this is quite high density, but what if you do not need this sort of density? You will have 30 LED per meter, you will have 60 LED per meter, you will have 144 LED per meter, or 300 LED per meter. And yes, 300 LED per meter is idiotically expensive. That's the whole point. You have to choose based on your application. So if you have any application where you're making neon sign and people are directly looking into it, people will pay for high density LED. And if you are putting it naked, where it's like, you do not have a diffuser, you may want to pay for it. Or if it's like reflecting on something that has texture, patterns, accenting something that has a bit of flavor to it, you may not want like sparse hotspots. You want it to be smooth. So in those sort of scenario, people will pay even for silicon sleeving and having very high density LEDs. So that's up to you. 30, 60, 144, there are many more, but be aware of it. That's a vector that you control and directly affects the price and power consumption of these puppies. And after that, after you selected that in Amazon or whatever have you, Alibaba and all that, then you will have to select the coatings. So generally this puppy is naked, good enough for indoor use, but again I have to use it indoors. Again, Diwali is an outdoor kind of festival for us, so yeah, this will go outdoor. Let's see how long it lasts. And then you have one step above that, which will be a silicon coat, basically almost a glue-like a structure on top, which again, it does allow it to survive rains, but not very durable. Like, it's good, but not very robust, so to say. Again, more than good enough for most outdoor scenario. And then you have daddy units, which are like this, which again, it's a complete silicon case, meaning nothing should happen to this, even if you have these things underwater. And please fire anybody who puts AC live in a swimming pool. Again, no matter how good silicon is, you do never have one point of failure. So never have that. DC is not an issue. Unless people open their mouth in a swimming pool and they're like, okay, why my tongue is tingling? So yeah. So in those sort of scenario, you have to understand. You have 3 options. So very basic naked, you have a basic coating, which again, for more than enough people, is like just shut up, take money for that layer. And then you have full coating. Again, if you are in a harsh environment, salty environments, yeah, then you go for stuff. And again, be mindful, while silicon and all that is good, they are very vulnerable to ultraviolet. Not as vulnerable to as plastic, but again, they are vulnerable. Again, degraded. That's how I know that they are not indestructible, so to say. And again, it may be depending on the quality of the, silicon used. And again, all silicon cases, mobile phone silicon cases, they yellow because of ultraviolet. Same thing. So try to keep them under a shade. Basically, if you have a trim, have the shaded part be covered with this, not the exposed part. You always want it to be shaded. That will give you a much longer lasting LED strip. So you have to worry about voltage, power injection I have cleared, indoor lighting. Now be mindful, for mood lighting, many times people will say go with analog system, because again, at subtle lights, these are very effective. And if you want a work light, do not trust this. You're like, even if you can set this to white, for example, let me try to find the remote. Yep, here's the remote. Let's set it to white. Yeah, you can see it looks-ish white-ish, but it's not to human eye. It's very ugly. And if you have to read in this light, it's going to give you a very bad headache. So trust me, do not expose someone for this white light. It's not supposed to be there. Now, because there is a need for it, people are like, what if we have a dedicated LED for that? So this LED is RGB, simple. There is a RGBW LED. So RGBW LED, there is a fourth channel. That channel is only for white LED. So if you know about your LEDs, you know for a fact that there is no white LED. All you have is a blue LED that glows into a phosphor. Phosphor fills on the blanks. That's a very good way of getting light done, very efficient. We do it, but again, because this is a decorative light first, they focused on cost. The phosphor used is very low grade. Even the best super duper expensive one, they barely give you CRI of 70, which translates to poop. It's useless. To solve that, now there is 5 channel LEDs, which you have red, blue, green, cold white, warm white. That's a bit better, but still nowhere near as like a proper tube light and all that. So trust me, if you want white light out of it, white fill light, I could see that. White light as a like, primary work light, even with those 7 channels, yeah, not worth it. Just like if you really want like, manual control and all that, have this as a like, RGB control system, and then have a dedicated warm white and cold white transfer light. Because again, those are lights meant for work light. So they have generally very high quality COPs. The actual LED, the actual phosphor is very high end on them. So they are very good. Like one example is TM1834, which has RGBW, but again, do not use it for white lighting. Like primary lighting, hell no. Again, if you want to use that for inside your computer cabinet, go YOLO. But again, as a work light, any sort of actual light where people are working, don't. Just no. No. Now, what about the control? Control, thankfully, this one you have, because again, this WS2811 is so popular, you have a lot of option with these puppy. For example, this cheap option you see infrared LED. Here, there is no LED. How the heck it's controlling it? It's a radio frequency. And again, be mindful, if depending on what you want, you can get Bluetooth controlled, Wi-Fi controlled, or basically IR control, or in my case, radio control, meaning this remote can work even if it's not directly looking at it. Ta-da! Ta-da! Huh. Green color shows blue? Oh, green is of 2 lights, that's why. Yellow, let's see what yellow does. And then, ta-da! So, you can do whatever you want, it will work. So again, even though it has LED, I'm pretty sure this is a combi remote, meaning it's supposed to work with people who are buying infrared one and people who are buying the radio one. So all of them are available. It's very interesting. So these are the information that you have to be aware of. And again, if you want, you can make it by yourself. And benefit of this, yes, it can be integrated with, Siri or Home Assistant if you want to. Again, why would you want to? But like if you want, you can do that. So these are the option. Hopefully, I have made everything at least good enough for you guys where you can like, okay, I see what's happening, what I need to do. And I hope you have a very safe purchasing experience where you do not get fleeced with a fancy looking RGB, which is not proper RGB. So this was my presentation on LED lightings for decoration. Hopefully you have liked it, learned from it. In that case, please hit the like button, share it amongst friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.